Okay, so for question 1a, we have polar points. We're trying to convert them into rectangular coordinates. So we're just going to use the x equals r cosine theta, y equals r sine theta, which I'm hoping you've made that lovely connection to vectors. It's basically magnitude cosine theta, magnitude sine theta. So it's the same exact idea. Remember, that's r and that's theta. So I can just do 3 cosine, 2 pi over 3, comma, 3 sine, 2 pi over 3. And if these are special angles, then you'd be required to reduce them. So 2 pi over 3, that's a 60 in the second quadrant. So this is going to be a negative 1/2. And this one's going to be a positive square root of 3 over 2. And so if I just simplify that, get negative 3 over 2, and then 3 rad 3 over 2. So that's what this point is. And we can kind of do this quick little double check that it makes sense to us. So if we found 2 pi over 3, so that's like right here, and we're going in that direction 3. So that's in quadrant 2, which would have a negative x and a positive y. So our answer makes sense. We come over here. We could do this little drawing beforehand if we wanted to. So we could find where 60 is. So it's right there. Negative 2 means we're going to go in the opposite direction. So it's going to be down in quadrant 3. So our answers should both be negative when we do this. So again, just using those formulas up there, negative 2 cosine 60, negative 2 sine 60. I never managed to not write in my little space that I have there. I could have just written it down a little bit lower. Everything would have been fine, but no. All right, so we get this. Let's see. That's going to become negative 1, and this is going to become negative square root of 3. So, makes sense to me. We're negative negative, which is where we're supposed to be. So, boom, there you go. Question 1, done. So for number 2, we just have to plot these polar coordinates. So remember that we always start off with the angle. So if I'm looking at part A, I'm going to find 4 pi over 3, which is on this line here. I extend it in both directions, but it's important to note what's going on over here. If I wasn't on a computer, I would be handwriting 4 pi over 3, so I know that this is the main side of this line that I'm paying attention to. And then I just count 3 in that direction because it's positive 3. So 1, 2, 3, and there is my point. Come over here, same idea. 2 pi over 5, not a nice number to work with. I know that right here is 2.5 pi over 5 because this would be pi over 2. So just take half of 5, and I know that that's what's going to be here. So I'm going to approximate it as somewhere close to that, so like right there-ish. And here's where it's important. So I would label over here 2 pi over 5, and then because it's negative 1, I go in the opposite direction. So my point will be down here. Okay, so that's why it's nice to label where the actual angle is, not the opposite side of the angle, so that you know whether you're going towards that one or away from it, depending on if it's positive or negative. Down here we have negative 30, so that's going to be right here. And then I'm going 2 in that direction. So 1, 2, there's my point. For this one, we find negative 120, so that's going to be right here on this line. Yep, right here, there we go. And it's negative 2, so I'm going to go in the opposite direction. So if this is where 120 is, I go in the opposite direction, 1, 2. And there is my point. So that's how we graph polar points. For 3, we're given a rectangular point, and we're being asked to find all polar coordinates that satisfy these angle requirements here. So the first thing I'm going to do is just actually kind of draw this and figure out where it is. So I'm just going to do it right in the center. It's negative 2, and then up to rad 3, so that's going to be like right here, to rad 3. So from this, I can make a triangle, and I can figure out what the radius is going to be. So this follows the pattern 2x, x rad 3, so of a 30, 60, 90. So I know that this is going to be 60. So I know automatically my radius is 4, and I have this angle right here, theta, of a 2 pi over 3, so 120. So now that I kind of have all of that basic stuff down, we can actually try to figure this stuff out. So I need to use a positive angle to get here. So let's see, that's going to be this 2 pi over 3, and then I'm going a positive 4 out. So I have 4 comma 2 pi over 3, and that's going to be this point right here, which is the same as that point. But there's another one we could use, because if we were to select this angle down here, we could use a negative radius. and it would work as well. So we need to come all the way around the circle and figure out what this would be. It would have the same reference angle, they're vertical angles, so this is going to be 5 pi over 3. So I'll have 5 pi over 3. So these are the only 2 points that work between 0 and 2 pi. Now if we change this up a little bit, where we now have this weird negative pi to positive pi, so the way I like to think about it is this is basically anything in Q3 or Q4 you're going to use a negative angle for, and anything in Q1 or Q2 you'll use a positive angle for. So that means that this first one works, the point that we had over there, 4 comma 2 pi over 3. Down here, if we were to use this point, we can't use 5 pi over 3, so we'll use its negative equivalent. So that's negative pi over 3. And that's going to be the set of polar points that meet those criteria. Just as one last aside, if we were to find all polar points, we would basically pick like some of these ones, like these two right here, and just add the plus 2 pi k at the end, right? So we could do that for both of these two, and that would work. We could do it for both of these two, and that could work. For 4a, we're going to convert the polar equation into rectangular. So what we always are looking for is stuff from over here so that we can switch r's and thetas into x's and y's. None of them have a secant, so the first thing I'm going to do is just rewrite this as a cosine, and then I will multiply to the other side because there's nothing in the denominators either. So I will multiply this over, and I get r cosine theta equals 3. R cosine is really x, so this is really x equals 3. So I know that this is a vertical line. For b, we have r equals negative 3 sine theta. It'd be really nice if I had an r sign right here, so what I'm going to do is just multiply both sides by r. So over here I'll have r squared, and here I'll have my r sign. And then I now have things I can use. So r squared is really x squared plus y squared. And then over here I have 3, and then this r sign is now a y value. And whenever we get this, we always just keep going to put this in the standard form that we're used to. So I'm going to have x squared plus y squared plus 3y plus some sort of blank equals 0. So I have to do plus the blank there. I'm doing 3 divided by 2 squared. So that's going to be 9/4 up here. So I will add 9/4 on this side as well. So then I get x squared plus y plus 3/2 squared equals 9/4. So this is going to be a circle. It has a center at 0, negative 3/2, and it has a radius of the square root of that, so 3/2. And there we go. Done. For c, we have r equals cosecant theta. Nothing has cosecant, so I'm going to turn it into 1 over sine theta in the denominator, so I'm going to multiply to the other side. R sine theta equals 1. R sine is really y, so y equals 1. So this is a horizontal line at y equals 1. For d, we have r equals 4 cosine theta minus 4 sine theta. I really need r's over here, so I'm going to multiply every single thing by an r. So I have r squared equals 4r cosine minus 4r sine. R squared is really x squared plus y squared. R cosine is really x, so I have 4x. R sine is going to be y, so I really have 4y. So again, I have to keep going with this. So I'm going to do x squared minus 4x plus something, and then I'll have plus y squared plus 4y plus something equals 0, but I have to have 2 plus somethings for the 2 different completing the squares that I'm going to have to do here. So let's see, this one's going to be a 4. This one's also going to be a 4. So I get x minus 2 squared plus y plus 2 squared equals 8. So I know that this is a circle. Forgot how to spell circle. Let's see, it has a center of 2, negative 2. It has a radius of the square root of 8. For question 5, we have to convert the rectangular equation back into polar. So that means we need to reintroduce r's and thetas, and then we typically try to solve it so that it's r equals when we're doing this. So if I look over here, x is really r cosine theta, so I can just replace this. R cosine theta equals 3. If I solve for r, I need to divide by that cosine, and then I can just simplify that up a little bit by just moving the cosine up to the top. So x equals 3 is the same thing as r equals 3 secant theta. 5b, we'll do the same thing, just replace x and y with what we have over there. So this is going to be 2r cosine theta minus 3r sine theta equals 5. And our goal is to try to get r by itself, so I'm going to factor out an r. So I'll have just a 2 cosine minus a 3 sine times the r equals 5, and then I'll just divide this to the other side. And it's not really a clean answer, but this is the best we're going to get. And it's really important, you cannot bring these up as secants and cosecants. They can only do that if there was no addition there. So don't try that. This is the final answer. 5c, we want to do a little bit of work before we actually just directly substitute those values in over there. If we were to do that, we'd have to try to FOIL with an r cosine theta minus 3. That doesn't sound like fun. So it's just easier if we simplify it first. So I'm going to FOIL this out and get x squared minus 6x plus 9 plus y squared equals 9. If I just simplify that just a tiny bit more by just putting the squared terms first, non-squared terms, and then anything else that's left over. And now this is much easier to work with. So x squared plus y squared, that's the same thing as r squared. And then I have this minus 6x, which I'm just going to, replace the x with r cosine theta equals 0. And we can actually just add this to the other side. So I'm just going to cheat and do that. And then I can divide everything by r. So I'll get r equals 6 cosine theta. Again, we just want to FOIL everything out first before we do anything. So I'm going to have x squared plus 6x plus 9 plus y squared plus 6y plus 9 equals 18. I'll group squared terms with each other. So x squared plus y squared. Non-squared terms, so plus 6x plus 6y. I have this plus 18. It's going to cancel with the other 18 on the other side. So I can just have equals 0. And now I'll just start replacing things here. So x squared plus y squared is the same as r squared. 6x is going to be an r cosine theta. 6y is going to be an r sine theta. I'm going to subtract these to the other side and divide everything by r. And I hope you're okay. I'm going to do that all in one step. So hopefully you survived that I divided everything by r and subtracted these over. And there we go. Boom. Donezo. For 6, we're given the location of 2 planes relative to an airport. So the airport would be at the pole or the center, and here's the polar coordinates for these 2 different airplanes. First thing I'm going to do is just kind of sketch a quick picture of this. So I have 12 is right here, and I'm going out 4, so that's going to be one of the planes. And then we have 72, that's like right here, and it's only going out 2, so I'll do that. And let's label that, that's 4, that's 2. The angle in between is going to be 60, so I just did 12 minus 72. And what we're being asked to find is that distance that's between them. So here we have a lovely triangle situation. I'm going to use law of cosines for this. So I'm going to have that d squared equals 2 squared plus 4 squared minus 2 times 4 cosine of 60. So if we do a bunch of crazy math there, let's see, this is math. 4 plus 16 minus, let's see, this is going to be minus 16, cosine of 60 is 1/2. All right, so we have 20 minus 8, that's 12. So d squared equals 12, so d is going to equal the square root of 12 miles. So that's how far apart they are from each other. We could also do this with vectors, and I'm not going to bother showing you that. If you really want to see it, it's in the answer key. You could go do that. We could also convert this to x and y by using the formulas and then use the traditional distance formula. That's the hardest and longest way possible, so I would not recommend. Either way, get the exact same answer.